Good day everyone! Today we're going to solve a problem under the Module 3 of Engineering Mechanics. This involves the concept of equilibrium of forces. So here is the problem, and I am tasked to draw the free body diagram and to determine the reactions at pin support A. So let's start.
So again, this is our problem, and for the free body diagram, I am just going to draw all of the forces acting on this beam. So in here, since point A is a pin support, this means that it has a horizontal and a vertical component. So in the free body diagram, I have labeled it as AX and AY. So next would be the downward force of 8 kilonewtons and the upward force of 8 kilonewtons, the moment at 2 meters, and the 30 degrees inclined force of B with respect to the y-axis. So since B is just a roller support, this means that it has no BX and BY. But since we're going to use this BX and BY to the summation of moments, I have drawn it here. So this is the free body diagram of the beam. So next, to determine the reactions at pin support A, we are going to solve for the moment of force at A. So since this beam is in its equilibrium state, this moment of force in A would be equal to 0. So in here, we are going to have negative 8 kilonewtons multiplied to the 600 millimeters converted to meters. So as you can see, this is in a negative value because it runs in a downward direction, and when this would be rotated, it would produce a clockwise direction. So it is said that when it would have a clockwise direction, it would be negative, and when it has a counterclockwise direction, on the other hand, we will have a positive one. So this 600 millimeters is converted to meters because the standard unit for moments or torque or moment of force is kilonewton meter. So going back, this is negative kilonewtons times 600 millimeters converted to meters plus the 8 kilonewtons because it is upward in a counterclockwise direction multiplied to the 1100 millimeters converted to meters, and this is 1100 millimeters because in here the distance from point A to this force is 600 plus 500 millimeters. So there. Next would be the moment of negative 2 kilonewton meters because it is in a clockwise direction once again. And last but not least is the negative BY multiplied to 2,300 millimeters converted into meters. And this is BY because this component of the B force is the one perpendicular to the distance. So this is equals to 0 because it is in the equilibrium state. So upon substituting the values, we will have negative 8 kilonewtons multiplied to 0.6 meters plus 8 kilonewtons multiplied to 1.1 meter minus 2 kilonewton meters minus P cosine of 30 degrees times 2.3 meters is equals to 0. So upon solving it, we will have 2 kilonewton meters minus B cosine of 30 degrees times 2.3 meters is equals to 0. Since we only have one known value here, we're just going to transpose it on the other side and compute the value of it. So upon calculation of the 2 kilonewton meters over cosine of 30 times 2.3 meters, we will have 1.004. So our B would be 1.004 kilonewtons. So next, we are going to get the summation of forces acting horizontally and in the x-axis. So once again, this would equal to 0. So in here we have AX and the BX only. So we have positive ax because it is going to the right side, and negative bx because it is going to the left side. So it is equals to 0. So ax minus negative b sine of 30 degrees is equals to 0. So ax minus 1.004, this was gotten from here. Sine of 30 degrees is equals to 0. So once again, we only have one unknown. So ax is equals to 1.004 sine of 30 degrees is equals to 0.502. So here we have ax is equals to 0.502. So moving on, and the last step, we're going to get the summation of all forces acting vertically, so in the y-axis. Once again, it is equals to 0. So here we have the component of AY, 8 kilonewtons downward, 8 kilonewtons upward, and the BY. So AY minus 8 kilonewtons plus 8 kilonewtons minus BY is equals to 0. This is negative because it is downward, and this is positive because it is upward. So negative BY because it is also downward. So let's substitute the values. So AY minus 8 kilonewtons plus 8 kilonewtons minus B cosine of 30 degrees is equals to 0. So here we get AY minus 8 kilonewtons plus 8 kilonewtons minus the B value of 1.004 cosine of 30 degrees is equals to 0. So again, since we have only one unknown here, let us solve first this negative 8 plus 8 minus 1.004 cosine of 30 degrees, we will have negative 0.869. So AY minus 0.869 is equal to 0. So transpose it to the other side, and there we will have AY is equals to 0.869 kilonewtons. So now we have already determined the reactions at pin support A, and these are my answers. So the value of B is 1.004 kilonewtons, and the reactions at A are 0.502 kilonewtons in AX. This is, since this is positive, it's going to the right, and since this is also positive, this is going to the upward direction. So there you have it. Thank you for watching. Bye bye.